Okay, Commodore C64 6502 microprocessor, packing and unpacking colour screen data, which is usually 0 to 15. Now what's the problem? Let's have a look at the red box. Bytes of colour screen data, so we've got 6 and 11, but notice the top half of the byte, the 4 bits called a nibble, is all zeros. The 6 is only in the bottom nibble. Same with 11 and same with 15. The top part of the byte is not used at all. The main data is in the bottom part of the byte, the bottom nibble, the bottom 4 bits. What we need is to pack these 2 bytes into 1 byte, so we get packed data where the 6 is at the top half of the byte and the 11 would be at the bottom half of the byte in packed data. Now we've got 1,000 bytes of screen data. We can pack that into 500 bytes, but the question is, what's the solution? How do we do it? Well, to pack our coloured data, what we need to do really is arithmetic shift left, because we'll take the 6, which is the bottom part of our nibble, 0, 1, 1, 0, and if we shift it, arithmetic shift left it, if we shift it left 4 times, we move it from the bottom part of the byte, the bottom nibble, to the top part of the byte, the top nibble. So then our byte would be 0, 1, 1, 0, and the bottom 4 would be 0, 0, 0, 0. And then what we can do is take our 11, which is the 1, 0, 1, 1, and we can OR that into the same above byte, and then we would get the solution, which is the 0, 1, 1, 0, 1, 0, 1, 1. So we've got the 6 at the top and the top part of the nibble of the byte, and the 11 in the bottom part of the nibble of the byte. So what we've got to do now is go to the orange box and code it. Code our routine called pack. So what we do is we load our first byte of 6 into byte 1, which is FB. We load our 11, which is the 4 bits 0, 1, 0, 1, 1, into memory FC byte 2. Clear the carry flag. Load the accumulator with our first byte of data, byte 1, which is of course 6, and then we apply to that the logical shift left. We do that 4 times, so we move the bottom nibble to the top nibble of the accumulator. Then we OR our second byte, which is the 11, which is the 1, 0, 1, 1. We OR that into the same accumulator, and then we store the result into packed byte, and the result of them operations is our solution, 0, 1, 1, 0 and 1, 0, 1, 1. So we've taken 2 bytes of data and compact it into 1 byte of data, and using 2 loops we can now rewrite this routine so that we can pack 1,000 nibbles of colour screen data, or 1,000 bytes of colour screen data of 0 to 15 into 500 bytes of packed data, and save space in our game code. But also, the beauty of this is once we've written the routine, we've written it for all time. We never have to rewrite it again. But what we can do is now rewrite our pack routine, which is fairly simple, in 68000 and also 386 assembler languages for the Amiga computer and the PC. Yeah, and we're laughing, but what we need to do now is unpack it. Ta-da! That's a packing. We need to unpack. And that will be the next video. Simple. So simple, even I can do it.